Welcome to the lecture series in computer science. As a part of this series, this is a course on artificial intelligence, and in this course we are in unit 3. Till last module we completed all the essentials of logic for reasoning purpose, and from this session we will see how to use logic and other search techniques somehow into the knowledge representation side. And today we will be seeing the basics of knowledge representation and why is it important in the computer science side, and then a quick recap of logic with the object oriented approach. This is going to be the primary basis with which our knowledge is represented, and it very well mimics the human way of representing things. So, we will combine the object representation also here. And from object representation there are certain disadvantages. To overcome it, there is a other method of representing it through the semantic networks. The advantages, it can combine some representation with a logical sense also, so that the reasoning is good enough. And to start with, what is knowledge representation and how is it different from the raw data that is fed into a machine? So, let us take an example. It say some sensor readings are there. So, we have the sensor reading coming in. Suppose you are driving a vehicle, we see the kilometer speed. So, that is actually some data coming in, or the text strings or some hexadecimal values, and these are some raw data that does not have any meaning attached to it, have a text, and we can extract all those data. Like for example, 42, it is a numeric value. Dog, it is just a string. Barks, it is just a string. And what is the relation between dark and barks? We have to have some kind of representation inside to specify the relation, and for those things we have some techniques of knowledge representation or structure we have to maintain. So, this actually gives more information to it. Say for example, dog can be a predicate and barks equal to true, that can be an argument that in terms of the logical expression that we maintain. So, this is actually one type of relation we can put it in KR, or KR here I mean as knowledge representation. And another example is a dog is an animal. So, this representation how we can specify. So, these we are going to see in this part of the unit. So, what are the knowledge tasks that are prevalent in AI methods? So, it helps in the following intelligent task. I have named only a few of it, maybe 2 or 3, but there could be more. Say the first one is reasoning. We have been doing reasoning for the past few weeks, where there are new facts, like the last example that we have taken, the food example. There we had new facts, and from the facts we are going to conclude what is unknown, or from the unknown we have to known. So, those conclusion, the deducing the fact, it is an essential part of reasoning, and this reasoning will come from logic side. Second example is the planning. For planning, in AI planning, we would have the starting state given the initial starting condition or the initial state and the goal. Can we get a sequence of steps or the plan? A typical example would be like the timetable planning. You have the initial state and the goal, how do we reach? Or if you take the missionary and cannibal problem that we did at the beginning of this course, where in the search techniques, where 3 missionaries and 3 cannibals are on the left side and they want to go to the right side of the bank, and there is a boat that can carry at most 1 or 2 members. So, there what are the sequence of steps that to be followed? This is called as a planning. So, in AI planning, it is a big area in itself, and how to represent those tasks in AI. So, that representation we will also be talking about. The third is in natural language understanding. Again, nowadays we are very much familiar with the large language models that are coming across, say ChatGPT or Gemini or other LLMs. So, how to interpret? Suppose you give a statement, feed a statement in the ChatGPT, how does it interpret? How does it know that the thought that you are writing is exactly the same as interpretation, and how is it responding, and how is it reacting to the natural language? So, these are going to be very important knowledge tasks, and how are we going to represent, how is the computer able to understand that? All those we are going to see in this part of the unit, how to represent so that a machine can understand. And the logic forms the basic stuff of the knowledge representation. And if we look at the recap of the entire logic side, we started with the syntax of the proposition logic, where we had say some literals of P, Q, R, and then we combined with the operators of say some the binary operators of OR and implies, double implies, XOR, and also we had another operator, the unary operator of negation. So, with this operator, this forms the syntax of the proposition logic. They can be combined. So, any fact we are going to represent it with a proposition logic, or if the quantifiers are there, then we are able to express it with predicate logic. Like in the last resolution, we used the predicate logic, the quantifiers for all persons, and for all food we use the quantifiers. Now, given this syntax, how are we giving the meaning to it is represented through the truth table in case of proposition logic, and ultimately we are going to evaluate it as to yes or no, or true or false, and if it is true, that is going to be the entailment. And the reasoning process again is going to have, from the set of facts are we going to deduce the correct the conclusion. So, if there is a proof associated with that, then we say that the reasoning process is valid. We can reason out or ask the question why. So, the answer to that will be in the form of a proof. So, that is the background of logic from this side, and how we are going to utilize it in the knowledge representation is what we will see now. Now, in knowledge representation, how we are going to use, it is a simple example. Suppose I say the first example is all mammals are warm blooded, and in predicate logic we would say for all x, if x is a mammal, then x is warm blooded. And the second one, which is connected with the first one, all dogs are mammal, if x is a dog, for all x, if x is a dog, then x is a mammal. You could see the connection between the first and the second. And the third statement is Scooby is a dog, the dog is Scooby, and if you note all the three statements, this dog is a predicate and mammal is a predicate, warm blooded is a predicate. The arguments are this Scooby is constant, this is constant, and this constant dog of Scooby, this can be substituted with this x, which is a variable, and this process is called unification. And this x, whatever Scooby, a dog of Scooby, so this would be substituted here, which would be mammal of Scooby, and mammal of Scooby, it's warm blooded of Scooby. So, if the question is Scooby warm blooded, using resolution or using some other forward or backward chaining, we would say the answer would be yes, and the answer would not only be yes, but how we got that s will also be given through as a proof, and that is the whole reasoning process. And this type of reasoning is possible only with logic. So, this we will be using regularly in AI techniques. Now, coming to the other representation of objects, this you might have done in as object oriented representation techniques, the same method. And why it is important is we mimic the objects, like how we think. Human beings think as objects. The same method is being represented here. So, why it is more important? One, it provides the modularity. Modularity is each of some objects can be written as a modularized, so that the concentration is more on one modules, and the modules can also be interacted with each other, and the knowledge with one specific aspect is encapsulated within that specific object. So, it provides some kind of modularity in that structure. The second advantage is it supports inheritance, and inheritance is something where in the previous example we had, where suppose if it's warm blooded, Scooby, whatever the mammal characteristic has, that can be inherited by the dog itself, because it is a part of mammal. So, that type of inheritance is supported within this object oriented representation. If it is not there, it would be very difficult, because we would be rewriting several things again and again. Third, it mimics the human cognition, like what I said. The human beings tend to group similar objects, and these similar objects, when we put it into certain categories, say we may not be able to repeat it again and again. So, it would be unique in nature, and we can apply one common rule to one specific category. So, that way the object representation will be much easier, and it enables hierarchical and compositional reasoning, a combination of other reasoning. So, we will see an example here. So, take a car, and usually we call that as a class. It is very similar to what you have done as object oriented programming. So, this car, we have a class called car, and within this class we have one instance of the car, and the car, it is actually of one brand, and here you see that as an object. So, the object is this car as an instance, and the properties of it is the color, which is red. These are the properties for the specific objects. Price, what is a kilometer, and what is a model. So, these are the properties, and attached to these properties are the properties values to it. So, color is red, price is given, the kilometers, the model, and here again I can have number of other properties. The advantage is, for this object I can have any number of values, and this can be grouped together. The methods are mostly the verbs, the actions that it does, or the behaviors. Here example is given as 4 examples of method. We have the start, backward, forward, and stop. These are the functions. So, if we are going to write it as a computer program, we would write for each of the method, we will have each of the functions, a small piece of code that could call. So, that part of it is called as a modularization of the code. So, within this method there will be only one function that is specific only to start. So, this is an example of the object oriented approach. So, if we see all the 4 advantages, this supports this object creation and how it belonging to the class. Now, there is another example of the animal kingdom, where the class is dog, and from dog the object, the name of the object is Tommy, where the name is Tommy. The age of it is 5, and the breed of Tommy is Beagle. And since dog is inherited, again it is from the class mammal. The class is dog, and the superclass is actually mammal, and since mammal has fur, that inheritance has come to this dog also. So, you can imagine as mammal, and then dog, and within this dog you have one part of it as Tommy, and which has age as 5, this breed as Beagle, and this mammal, the property has fur, since mammal has fur, this is inherited to dog and this is inherited to Tommy. So, this Tommy also has fur, and the methods, the functions is eat, since mammal eats, this is a function or the method associated with this mammal that also is inherited by Tommy, and bark, and this is actually from animal. Before this mammal eats, this is inherited from animal, which is again a super class. This eats occur actually is eats that gets inherited with mammal, and that mammal with dog, and that dog with Tommy. This is the inheritance of the method that is being adopted, and bark, and this bark is from the specific property of this dog. It is not with respect to mammal. So, for this dog we can apply all these inheritance property. Through inheritance it will apply, plus if there is any specific property, it would be applied to that specific dog also. Now, what are the disadvantages with respect to object oriented methods? The first one is rigid class hierarchy, that means there are no multiple inheritance properties or inheritance or categories that can be included within that object oriented approach. Another one is implicit relationship, that is encoded in attributes or method, there is no flexibility within that. The third, it cannot handle exception, and other one is reasoning capabilities is not possible. Now, in order to overcome all these difficulties, we are getting into the semantic networks. The semantic networks combines the logical formulation and we can represent in a simple sentence format. So, here knowledge is expressed as concepts, and this is actually a graph structure where we will have a node and edges. The edges are arcs are represented through the relationships. Say for example, this is an one animal kingdom example of the semantic networks. That say we have the two representation here of the edges or arc. One is a arc like here, another one is the properties eat. So, if you see the dogs is animal, animal is living thing, plant is living thing, cow is animal, and cow eats herb. This is a property. This is an instance. Now, with this type of representation with nodes as the concepts and edges as other is an instance or property, we can represent the semantic network. The advantage is that it can support inheritance, and this can be represented as a logic side. So, suppose if I take this as an example, cows eat herbs, I can represent as eats cow herb. So, in logic it would be cow eats herb. So, this is a predicate and cow herb is the argument. And while we do this, it can also support the reasoning, like we said about the forward or backward chaining or resolution. This can be put into prologue and ask for the reasoning. So, this is one example of a full a semantic network. Again I got it from this side, where we see, if you check here, bird is an animal, fish is an animal, and this is an instant, and penguin is a bird, canary is a bird, robin is a bird, and ostrich is a bird. These are the instances, and if you check the properties of it, bird travels by flying, this is property, covered by feathers, it is a property, ostrich travels by walking, and these walking, if you see, all these are nodes, whatever in the nodes are the concepts. penguin travels by, this is a property. Opus is an instance of, this is an instance, is a instance of, that is all an particular instance of category. The rest of it is going to be the properties. So, the properties or relationship is given by the edges. So, this canary is red, color is yellow, robin color is red, this travels by swimming. So, now what is the advantage with this? Suppose we say canary's color is red, it will also take whatever the properties that are mentioned by this animal. Animal covered by skin, those properties can be inherited by the canary also. So, this is the one advantage of the semantic networks. Now, this is another example. Now, what we are doing is, given these English statements which is in a simple sentence format, we are going to convert that into a semantic network with nodes and edges. So, given these statements, we have taken this as part of this flow, where we can see canary, bird, yellow, red. Now, given these English statements, the first task would be identify the nodes. The nodes you can see that are in bold. Canary is a bird, here canary is a node and bird is a node, animal is a node, sing is a node, fly is a node, animal and food are nodes, canary yellow is node. Now, we will construct the semantic network, where we will say canary, bird, animal, sing, fly, food. Whatever in bold, I am putting it as a node, yellow. So, all the bold things I have named the concepts. The property of it, so is a, can, needs, color, all these are the properties. Those properties I am going to write it as an edge. So, a canary is a bird, I am going to give it as an arc, a directed arrow, and it is an instance. A bird is an animal, again bird is an animal, it is an instance. A canary can sing, this is a property, a canary can sing. A bird can fly, this is a property. An animal needs food, this is a property. A canary is yellow in color, this is color. So, this is how we will construct the semantic network, and again the representation of it. So, if we represent as a predicate logic, write as is canary bird, we will just write bird of canary, I will write bird of canary, second animal of bird, third canary can sing, this is both are the constants. So, I can name like this, canary can sing or canary with sing, etc. That depends upon person to person. Bird can fly, now this, if it is a bird it can fly. So, it would not be bird or fly if X is a bird, then it can fly. The representation would be something like this. And animal needs food, similarly you can construct it. A canary is yellow in color, so this one would be color. of canary is yellow. So, something like this we can have. Okay. So, this is an example of the semantic network and a possible representation of predicate logic or proposition logic. Again, a few of it may need some corrections, but as and when we work out the reasoning process, this may be corrected. Again, what are the problems with semantic networks? Although it looks very simple and advantages with respect to the logical side, a formal semantics we have to work out. It is difficult, because if you see in the previous, we have the sing also as a node, a bird also is a node. Sing is not an object, bird is an object. So, how do we differentiate? What is the meaning of it? We do not know. So, there is a lack of formal semantics there. Scalability, what will happen if the number of sentences are more, and how does this network scalable? And having a large number of statements, it would be intractable. We would not be able to visualize it, and there is no means to detect the inconsistency among nodes. So, again the consistency has to be maintained. We cannot have the quantifiers. So, semantic networks as such, the quantifiers we cannot explicitly mention, and it has a limited expressiveness, and only the shallow inferencing is possible. Like I said about the inheritance, only those are possible, and other deep type of inferencing with respect to some kind of the resolution process or more details into it, like where we have all the theorem proving methods, we cannot use the entire structure into the semantic networks. Okay. Now, coming to the end of this session, what we have seen is, first we saw how a knowledge can be represented. One way is the raw data, but it is not sufficient. We need other type of representation that includes more knowledge, and that can be in terms of logic, that is on one hand. The other basic would be representation with objects, where we would have the instances belonging to a particular class or superclass, which is attached to the attributes or the methods with properties. The advantage there is the proper inheritance and the relationship that we could maintain. Another part, but that had the object oriented has certain disadvantages, and because it is rigid, and in order to overcome some of the disadvantages, there is an option of going into the semantic networks, and that representation is simple, that is given with graph with nodes and edges, nodes as concepts and edges as arcs. And again the semantic networks is not complete, there are certain disadvantages, and to move across the other type of representation, in order to overcome those disadvantages, we would see in the next session some representation with frames as well as ontology. Thank you.